Negative binomial and geometric distributions are two families of discrete distributions that are very important in statistics. The geometric distribution is so named because the values of the geometric density are the terms of a geometric series, while the negative binomial distribution is sometimes also referred to as the Pascal's distribution. Learning outcomes for study section 11. At the end of these study sessions, students should be able to describe the negative binomial and geometric distributions, establish the relationship between the negative binomial and geometric distributions. Negative binomial distribution. Consider a succession of Bernoulli's triads. Let P of R denote the probability that exactly R plus K greater than 0, in bracket, triads are needed to produce K successes. This will so happen when the last triad, that is R plus K triad, is a success with probability P, and the previous R plus K minus 1 triad must have K minus 1 successes with probability R plus K minus 1 combination K minus 1 P raised to power K minus 1 Q raised to power R, where Q is equal to 1 minus P. P of R is equal to probability of K minus 1 successes in X plus K minus 1 triads times probability of X plus K success is equal to Note that R plus K minus 1 combination K minus 1 P raised to power K Q raised to power R is equal to 0, 1, 2 is equal to R is equal to 0, 1, 2. Summation at 0, infinity, P of R is equal to equations 1 and 2 for K greater than or equal to 0 are known as negative binomial distribution. Mean and variance of the negative binomial distribution. Mean. Recall that the moment generating function MGF of a random variable x, m of t is equal to, using the moment generating function approach, therefore from equation 1, the MGF of R is but 1 minus x in bracket raised to power minus n is equal to, for minus 1 less than x less than 1. Therefore, m of t is equal to, now m of t is equal to, e of r is equal to, e function of r in bracket squared is equal to, complete the solution using v of r is equal to geometric distribution. If in equation 1 we put k is equal to 1, we have is equal to, and q is equal to 1 minus p, we have geometric distribution. The following describes the geometric distribution. Consider a sequence of Bernoulli triads with probability p of success. This sequence is observed until the first success occurs. Let R denote the number of failures before the first success. For instance, if the sequence starts with F representing failure and S success with F, 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 S, then R is equal to 3. That is, this distribution describes the event of first success after nth independent triads with probability rho, 0 less than rho less than 1. Moreover, the probability of such a sequence is P. R is equal to 3 is equal to. Generally, the PDF f of R is equal to of R is given by f of R is equal to 0, 1, 2. F of R is equal to 0, 1, 2. Equation 1. Some authors define the geometric distribution by assuming 1 instead of 0 is the smallest mass point. The PDF then has the form f of R is equal to Mean and variance of a geometric distribution. Consider equation 2. Mean. Let 1 minus p is equal to q. If function of r is equal to but q plus q squared plus q raised to power 3 plus is equal to q into bracket 1 plus q squared plus q raised to power 3 plus bracket closed is equal to, therefore, if function of r is equal to, if function of r is equal to 1 over p, variance, if function of r squared is equal to, recall that thus the mean and variance of this form geometric distribution are 1 over p and 1 minus p over p squared, respectively. Example 1. A fair die is cast on successive independent trials until second 6 is observed. What is the probability of observing exactly 10 non-6s before the second 6 is cast? Solution. This is a negative binomial distribution problem. So, r plus k minus 1 combination k minus 1 in bracket p raised to power k 1 minus p in bracket raised to power r is equal to 0, 1, 2. Therefore, we have is equal to 0.049. Example 2. Team A plays Team B in the 7th game with series. That is, the series is over when either of the teams wins 4 games. For each game, row into bracket A wins. For each game, probability of A wins is equal to 0.6 and the games are assumed to be independent. What is the probability that the series will end in exactly 6 games? Solution. The game will end is either A or B wins the game series. Probability of game ends is equal to probability of A wins series in 6 games plus probability of B wins series in 6 games is equal to 0.299. Note that probability of A wins series in 6 games is equal to probability of A loses 2 games before 4 wins is equal to example 3. In a sequence of independent rolls of a fair die. 1. What is the probability that the first 4 is observed in the 6th trial? Solution. This is geometric distribution problem. P into bracket R is equal to 5 is equal to 0.067, where R denotes the number of non-4s before the occurrence of the first 4. What is the probability that at least 6 trials are required to observe a 4? Solution. P R is greater than or equal to 5 is equal to 1 minus P R is less than or equal to 4 is equal to PR 0 is equal to 1 over 6. PR is equal to 1 is equal to 5 over 36. PR is equal to 2 is equal to 25 over 216. PR is equal to 3 is equal to 125 over 1296. PR is equal to 4 is equal to 625 over 7776 is equal to 1 minus 4651 over 7776. Complete the solution. Summary of study section 11. In these study sessions, we have studied 1. The negative binomial and the geometric distribution. 2. The probability distribution of negative binomial distribution is given by 3. The geometric distribution is a special case of the negative binomial distribution which holds when k is equal to 1 and is r is equal to 0, 1, 2. This is the end of study section 11. Thanks for listening.